favor. Could you do me a favor?
What, Nate? What's wrong?
This is hard right now.
What?
I was gonna ask if you could like taste like a little bit of rice and say if it's not hot, and then wait a little while and tell me when it's
Nate, really? This rice will get cool, Nate. Go over there and eat the food. Sure. Hello, people. How are you doing? Is my speaker working? Somebody say something.
Yeah, we can hear you.
Okay, good. And I can hear you too. All right. Good stuff. Let me use my speaker. Okay, so welcome to another episode, right?
Hi, sir. Welcome.
Looking for the charger for my. Okay, I'm gonna use this charger. No, man, Daddy not gonna kill you.
Oh.
Let me see. Okay. What's our mission today? Today, let me see. This week we're moving into 3D, so we're moving away from 2D, right? We do need to answer that question that we posed last week. And I want to also tell you about some other stuff about images that will kind of round off our journey as it relates to images, right? So, without further delay. Okay, so anybody got that question?
I was asking something else.
Oh, what was it?
Seeing that I've kind of been through this zine, and you always have an issue with the waiting room, you want help with that?
Yes, sir.
Oh, I normally disable the waiting room, you know, once I start.
I'm hearing the doorbell, and I think the doorbell means that somebody's waiting.
Oh, you're hearing the ding ding?
Yeah.
Oh,
Never mind.
When you hear that, is somebody coming in and out. But yes, I realized that challenge. Hold on. I realized that challenge a while back. It's kind of hard to be letting people in and out. So as soon as the class starts, I normally just disable the waiting room and people just come in and out. So, you know, I keep hearing that doorbell every time. Okay, so you're saying something else?
Nope.
Okay. All right, so let's quickly look at that that challenge that I posed last week, and then we move on to this week. I want to talk about some other terms apart from resolution and stuff. Where was that question again? It was in, no, I put it on the website. Yes, I did. Design computing JM, and let me switch over to the desktop. No. Right. Scan converter. All right, good. All right, it should pop up. Oh, there we go. All right, so if I log in, DDM, might go 2021. Dum, 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 dum. Ah, there we go. Okay, so what we posed was this question, right? So we said that we wanted to print a poster on 24 by 36 inch, right? Which that's essentially the size of a RHD blueprint, right? Those big blueprint drawings. Everybody's supposed to know this size. So you need to purchase a camera that when you take a picture, it will go on a 24 by 36 and it will not be blurry. What camera should you buy? A 5 megapixel, 15 megapixel, all the way up to 100 megapixel, right? I mean, if you can afford it, just buy the 100 megapixel one and done, right? Right? But usually that's not the case, right? So we want to use this formula to kind of work it out real quick. I'm gonna grab my wait, go again. Whiteboard, right? That's it. Microsoft whiteboard. There we go. Let's put this over here. Put that over there. And let's open a new board. All right, so this is what we are faced with, right? And where's my pen? So we know already what megapixel means, right? So if I look here and say, okay, my first option is 5 megapixel camera. So we'll start with the cheapest one first. So 5 megapixel means how much pixels, megapixel means how much pixels can fit in the screen, right? And if you remember that presentation, it's essentially adding up how many square dots can fit in this image, right? How many dots fit in the image? That's when you work out megapixels. So 5 megapixels, by taking the square root of that, we can get that answer. So that's roughly about, you know, call it 1,400 by 1,400 pixels, right? And we know what the pixels mean, right? Any image we have on the computer, and I can just grab a random image here. Let's say this image here of Nate, right? This is an image here. And if I open this image in your regular photo viewer, which is that, and I look on file info, there we go. I see where it is a 5,000 by, what's that? 3,125. That is the size of that image, right? But the main question that we want to know is, what size can this be printed on? Everybody get me? So in our case, that we were told that, okay, so we have the first option is a 5 megapixel camera, which when you take a picture with a 5 megapixel camera, it can take a 1,400 by 1,400 picture. So 1,400 by 1,400 what size can that be printed on? So we want to use this formula, right? And this is the same thing as saying, if I found an image on Google, and when I look on the properties of the image, it tells me that it is 1,400 by 1,400, and you want to know what size can that be printed on. So you might say to yourself, okay then, so here is my resolution. So 1,400 by 1,400, right? That's pixels, right? Now, so the deal is that it is the resolution over the DPI, and that gives you the real height. That's what we want. We want to know what the real height is in real life. When you go to the printers and print it, we want to know what that translates to. So we have the resolution here, right? We have a height resolution of 1,400 and a width resolution of 1,400. So we have the resolutions that is taken care of. How do we get the DPI? What determines the DPI again? Come on, we discussed it last class. What can you use to determine what is the value of the DPI? Nobody?
Sir, I don't know.
I can't believe we have totally forgotten. Wow. Well, if you don't remember within a week, no doubt you won't remember it over a semester or a year. So we're hopeless, but it will come back and haunt you. Don't worry. And you will dig up back this formula and work it out. When you have a very tight budget and you need to print 10 sheets and you don't want to print a sheet that is blurry. Can you imagine getting back all your sheets and all your images are blurry? Yeah, I know. Okay, so the DPI is determined by the experience of the viewer. Remember, so when the experience is closer, you use a higher DPI because your eyes are much closer to the content, right? Remember we did that example with this magazine here and we said, okay, oh, you're not seeing my camera, my bad. Right, remember we did with this example and we say, all right, if I'm this close, that means I need to use a high DPI because I can actually, my eyes can actually see the pixels. So I need to put more resolution. If I'm this far or 10 feet away, I don't need to use a high DPI. And of course, if I'm like the billboard size away, I can even use a lower DPI. So we came up with 3 values. We said, all right, when I'm really close, we want to use 300 DPI, right? Which is for documents. Most programs default to 300 DPI, right? Because especially like a Word document, because you're like right in front of the document, it's going to suggest that you use 300 DPI. Something that is not so close, you don't have to use 300 DPI. I mean, you can if you want it to be overkill. And definitely for a billboard, you don't need to use 300 DPI because your eyes aren't that close to see the dots. So no point in doing an overkill. Now, of course, people will argue that. People like, you know, like Apple people that tends to have high resolution stuff. But anyway, so what I'm getting at is that we said we wanted to print a 24 by 36. Now that is not going to necessarily be, let's say it's not going to be a close-up document. So we don't need to go to 300 DPI. But it's not going to be a billboard, so we can't go as low as 100 DPI. So let's try to work it at around middle, which is 150. So the DPI is the experience of the viewer. Always remember that, right? This is what catches most people. Okay, so then what is the real height? All right, So 400, so let's put that in perspective now. So that is 1,400 divided by 150. And that gives me, who have a calculator to work it out? Come on.
It's 9.333 occurring.
All right, so 9.3 what? Inches.
Yeah, inches.
So, and is 1,400 by 1,400. So if you get what is the real height and the real width, you're going to get the same because it's the same resolution. So a 5 megapixel camera can, let me just put that in perspective here. Stop doing that. All right. Sorry, I'm talking to the computer. All right, so a 5 megapixel camera, that's a camera, right? 5 megapixels is equal, can print me a page that is 9.3 inches by 9.3 inches. Fair enough? And it will not be blurry. So if I take a 5 megapixel camera and I print it on a 24-inch by 24-inch, what will happen when you pin that up? I think you're muted. Everybody muted, so I only see your mouth moving, but I can't tell you.
Blurry, sir.
Exactly, it's going to be blurry. But I tell you a secret, when you're looking on that image on your computer screen, it's going to be nice and sharp. But when you put it on your page and send it to print, it's going to be a big blurry mess. That key point is important because when you work out the formulas, you can clearly see that, okay, if my resolution is 1,400 by 1,400, then at 150 DPI, and remember that is determined by the experience, you're saying that I'm going to be a certain distance away, then I can print this no bigger than 9 inches. So you know what that means for you guys? That means that on your 24-inch by 24-inch sheet, if you wanted to use this image, you would have to ensure that your image, as in when you place the image on the sheet, it is no bigger than 9 inches by 9 inches. It don't mean you can't use a big sheet, you know. It just means that once you stretch the image larger than 9 inches by 9 inches, it is in the blurry range. It's going to start getting more blurry the more you stretch it. Everybody understand that?
Yes, sir.
All right, very important for you guys, right? So right away, but let's find the right answer first before we move on. I'm trying to go through this lesson quickly. So obviously that can't work because that's going to give me a size of 9 inch by 9 inch, and I want to print it on a 24 by 36, right? Meaning I want to fill up as much as possible the 24 by 36 page. So right away, I need a bigger camera. So let me skip 15. Let me go to 30 megapixels, right? So a 30 megapixel camera will give me 5,400 by 5,400. So let's work that out. So 5,400 divided by, and we're using the 150 DPI because that's how far we'll be away from it. We're saying that the page is not going to be right up in front of it. It's going to be a certain distance away, 10-ish feet, 5-ish feet, thereabout. What size does that give us?
36 inches, sir.
How much?
36 inches.
36 inches. Aha. So there we go. So we know that if we find an image that is 5,000 pixels, then when you print that on a 24 by 36, it will look nice and sharp when you fill up the page, right? And let me tell you why this was important. When I And for a lot of CSA students, remember that sheet that I showed you, I think it was last week. Which week was it? I don't even remember. I think maybe it was this one. Lecture files. No, not that one. Must have been the week before. Week before that. Crap, I don't remember. Anyway, let me use this as an example. So let's say you have a nice rendering and you want to, that needs to be on your sheet, one of your sheet, and you're investing in rendering this image so that you can have it as your like title sheet, you know, and it says, you know, the library or whatever you're designing. You want to ensure when you render this image and you invest on printing it out on that sheet, which by the way, they charge you more for colored prints, it won't be blurry. So you would need to know what resolution to render at. Now, here is the thing. Depending on what program you're using, you might say 1,500 is enough by, I don't know, 2,000. And maybe that takes you 4 hours to render. I don't know what program you're using, but let's say it takes 4 hours to render. Then you might say, because it takes 4 hours, that must be a nice resolution. But I expect you guys to take the kind of scientific approach to it, where if you work out what resolution it should be, then you would let your program render it to that resolution. So if you have to wait 5 hours, you're waiting 5 hours for an image that can actually work. Okay? All right, so this rule holds true whether you find an image on Google, whether you're going to use your phone and take an image, or whether you're going to render an image on your on whatever 3D program. Once you know the resolution and once you know the experience, which is why an artist will always, when you say, design something for me, the first question should be, what do you want it for? Do you want it for your phone? You want it to be printed? What do you want it for? Because that determines what DPI value you choose. So to wrap up this kind of image size lesson, let me just throw in a little wrench. And this is something that normally happens to you guys. What if you're printing on a 24 by 36 inch sheet, but it's not meant to be like at a distance. It's meant to be right up in your face like a document. So imagine you have a sheet like this and you want to print your sheet so that with the intention of the viewer experiencing it like this close, not from presentation, quick distance, but like right up close. What would that mean for your formula? What would that mean for your DPI value?
The DPI is 300.
Exactly. So let's use the same solution here. So we have an image that's 5,400 by 5,400. So at 5,400, if we now decided that we wanted to be closer to the image, so we use a 300 DPI, what real height will it give you as a result? Anybody?
That's 18 inches.
Exactly. So what you notice here? What you notice here between these two values? So what this is simply saying,
half size.
What this is simply saying is that the closer you are to an image, you will need to have a higher resolution for it not to appear blurry. The further you are from an image, you don't necessarily need a high resolution for it not to appear blurry. Which makes sense, right? If you're going to be closer to an image, it's more likely that you will perceive the blurriness. But if the image is going to be far or tiny, like a phone screen, it will not look blurry. So that is exactly what this formula is saying. So technically, you could lie to yourself and put in any value for this DPI here. But this is where the truth lies. right here in that DPI value. That DPI value represents how you will experience the image. And you have to be truthful to that value. So if you are saying to yourself that, look, I'm going to print this magazine, and it's a magazine, people are going to hold it right up in front of them, then that value needs to be 300 DPI. And what usually happens to artists who understand this is when you go on Google image search and you're digging down the place trying to find that perfect image, and you find the perfect image, but when you do this formula, you realize that it's going to be small. And this is why an artist would, for example, have those stock image websites that they can go and find an image at varying resolutions, because they know that depending on how the viewer will experience the image, that will determine the DPI. All right, now I want to just kind of, because this was supposed to wrap up from last week, but I normally end up spending like more than 2 days, 1 week on this, just to drive it home, because more and more, every time I go into the final, what's it called, in final crit, when you guys pin up for exhibition, which we may not have this year, but anyway, who knows? But every time I go into exhibition, and I see these nice big 24 by 36 inch with the title and everything, and then it's blurry. I'm like, really? Why am I here? Don't it? So I expect you guys to know about this formula and use it so that you can ensure when you take your photograph or take your renderings, it's not blurry. So that kind of concludes our journey on image size. I'm hoping that we can.
Sir, bring up what the formula, the big screen. Let me see it there again.
It's, don't worry, it is in your it is under unit 2 on the website, so you can get it anytime.
All
right. So of course, if you had 2 different resolutions, you would need to work out the real height and the real width. It's just that in this case we use a perfect square, right? Now, what I do want to run through this week is another kind of confusing, mysterious topic, right? Maybe I'm going to end up spending 2 weeks on it again, but it's necessary. It is necessary. And a lot of people don't know what this means. I'm going to show you. Let me just grab an image here. Let's take this photograph here. I wanted to use a real photograph though. So let me look on, where are we now? Image depth. Yeah, let me take a look on image depth here. Right, let's use this picture here. Let me open that in image viewer, which is our regular Windows image viewer. So I'm back to this image, right? So when I look on the properties of this image by going to image info, and I see the resolution here, this image property is not the real one. Let me look in the regular Windows image properties, right? Which is this window. Let me zoom in. Right. So this is the one we might be familiar with. Any file we right click in Windows or Mac will have its properties, right? So we go to details here and we see some information. We see like an image ID and all this bunch of stuff, sRGB. Look, we even get the camera maker. And does it have when it was taken? Yeah, this is 2013, right? But anyway, check out this value right here. So we have our bit depth, right? And this is, I think, a little bit confusing to persons when you talk about bit depth. The more you use Photoshop, let me open Photoshop here, you will notice that Photoshop has a thing where you see an 8-bit image or 16-bit image or 32-bit image. And sure, a lot of, yeah?
Now I really see a screen so clear now.
Oh, yes. I just remember I didn't share screen. You
The
should have told me
resolution
that.
is low.
Yes, you should have tell me that
I
earlier,
thought it
man.
was only me.
You should have told me that earlier. All right.
So he sent me one.
All right. Good. And it should pop up. No, good. So now we're nice and sharp again, right? Right?
Yes, sir.
Yes, sir, it's better.
Okay.
Yes,
So
sir.
yeah.
You might have to zoom in on some things still, but it better.
Yeah, man. Yeah, man. Okay, I will. Right. So we're talking about this thing that says bit depth. And I want to just touch on exactly what that is, because it does affect you just like resolution, but maybe a little bit less than resolution. Resolution affects you a lot more, especially, as I say, when you print something and it ends up being blurry. But this is a little bit different. This is just information that you need to understand about images, right? Let me swap this around. All right, so a bitmap image. We kind of touched on this a little bit last week, so we know that an image is made up of pixels, blah, 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 right? So don't need to go over that. Now, let's look at this thing about the bit of an image. Is an image 8-bit? And why is it that you will have some image that is a 32-bit image? You have some images that your phone won't be able to open. There are persons here that when they see 16-bit image, they get confused with bit and resolution. So I want to point this out to you, and it's up to you if how you want to retain this info, right? Now, this particular image that you're looking at, right? It has 20 pixels, a resolution of 20 by 20, meaning, does this have a pen? Right, good. Meaning okay, that pen is crappy. Let's go with my other pen, which is way nicer. There we go. Let's go with my, that pen, good. So meaning that on that axis, it has 20 pixels. That's really a horrible pen size. It's way too big. And on this axis, it has 20 pixels, right? So we know that already. That is confirmed. Now, in this particular image though, it only has pixels that are either black, like what you see in the A, or white, meaning the empty space here. So because you have these two types of color, either you have a black pixel or a white pixel, it's called a 1-bit image, meaning the pixel can either be black or white, nothing else. And that's really how you get a black and white image. If you remember, when you applied that photocopy filter in Photoshop, that's exactly what it did. What it did was cancel out every colored pixel to be either be black or white, not even gray. So once it's black or white, it's what you call a 1-bit image, right? Now, let us move on. Let us clear the screen. So that is what we're trying to get at is, what does that 24-bit depth mean? Because every image editing program, every TV you buy, every phone you buy, everything that has a pix that shows you anything on a screen will have a bit depth. So you have to follow me on this one, right? Was I recording this thing? It should auto record. Let me make sure in case you want to go back and watch it, because yes, it's recording. Good. So this black and white image, right, has 256 possible shades of gray. Now, I don't know if you notice, almost every program that you use on the computer, you will see this kind of a thing here where you see 255. You might see this value very often, and that is because whatever color that is displayed can only be divided or shown as 255 shades. So put it this way, this black image here now, which is kind of a grayscale image, is only possible to show any pixel within that 256 range. And notice that you keep hearing values like 256. I don't know if you've ever tried to buy a memory or a thumb drive and you're always seeing 8 or 24 or 16 or 64. And you might say to yourself, but everything that has to do with the computer is always in the what you call it, the multiples of like 8 or 2. Everybody ever notice that? So it is just based on how binary works. Now, what this is saying is that every single pixel in this image has the ability to show 256 shades between black and white. So therefore, this image is what you call an 8-bit image, or rather, it has 8-bit color depth. It is able to show 256 shades. So for example, oh, right, I have the example here. I do have this image somewhere. Oh man, where is that image? Oh, I thought I had it in here. No. No, discard that. So I'm going to save this image here. I'm going to just save it in this folder. I probably have it in some other folder, but I can't really go back to search for it now. So I'm just going to take it back out of PowerPoint just to kind of illustrate this point real quick. All right, there we go. So if I open this image in Photoshop here, there we go, and I zoom in all the way till I start seeing these pixels. Okay, you can stop zooming now, good. So you're seeing all these pixels now, right? Every one of these pixels have the ability to show any shade between black or white, 256 and 256 steps. I think you kind of do this with West Martin. You ever did like a grayscale? Where did that? No? Oh,
Yeah, we did.
You're not getting any of this fun, but anyway, I don't blame you because it's really years after I left school. I'm like, oh crap, that's what I learned in this West Martin class. That's the thing about this teaching thing, you know, you guys don't realize it until years after. But anyway, so because every pixel can show anywhere between 0 and 256 shades of black, it is known as an 8-bit image, which really works out to 2 to the power of 8, right? Now, don't fret, we're not going to go into any heavy mathematical thing, all right? You just need to know that's what it's representing. Now, we're coming, remember, our objective is that we're trying to understand what this is, because every image that you have on your phone, on your computer, every image on the internet says 24-bit depth. And you really want to understand what that means. If you're going to graphics, this is going to be important for you. Okay, so let me clear that. So what this is saying now is that a 1-bit image can only show black and white, which looks very much like a photocopy image, right? A 2-bit image can only show 4 shades of gray. So an 8-bit image, which is this one here, can show up to 256 shades of gray. You get what I'm saying? And so forth and so forth. Now, the other thing is that your monitor or whatever, your phone or whatever you're looking at has to also be able to show these shades of gray. Because think about it. When you have a picture, and a printed picture, which is probably like an 8-bit image, it has millions of colors. But when you put it in a photocopier, which is only able to see 1-bit color, black or white, then everything will get averaged down and then it looks like that. So if you were trying to look at an image on a monitor that was 8-bit, which is back in the day, sorry, in 1-bit. Back in the day, you used to have 1-bit monitor and 2-bit monitor. Those really old school monitors that can only show you that. That is what it used to look like if you try to view graphics on those monitors. So let's move on. So here comes the interesting part. Now, we all know about the primary colors, right? Right? What's primary colors? Somebody, just throw a quick definition at me. Come on, what's primary colors? Oh my goodness.
Pure color, sir.
Say again?
Pure color. Color.
50% for that answer. Come on, guys. What's so special about primary colors? What is primary colors? Come on, nobody Google it. You should just roll off the
Colors that can't be made.
Yeah.
Colors that can't be?
Not made from other colors.
Made from other colors.
They can't be made from other colors. All right, that is also true. So you get another like.
Use those colors to obtain other colors.
That is right on the money. Primary colors can be used to obtain any other color on the color spectrum. Yes, there are other stuff about primary colors about, you know, you can't mix colors to get it and blah, blah, blah. But what I want to focus on is the fact that it is used to get every other color. So give me the primary colors. Come on, this is basic school.
Red, blue, and yellow.
Red, blue, and yellow. I could even ask Nate. He's here with me. Nate, what's primary colors? See, he knows that as well, right? And I think he was quicker than you guys.
Internet a log, sir.
Anyway.
Computer slow.
Okay, I hear you. But what I want to tell you guys is that there are other primary colors apart from red, yellow, and blue, right? Hold on, what? So there is, where's my whiteboard? Do I need a whiteboard for this? No, I'll just write on this. So there is red. Well, what do you say again? Go again.
Red, yellow, and blue.
Red, yellow, and blue. But there are other primary colors that exist. Here is another one.
So oh, that's what they always say, RGB scale.
Wait, there's more.
M1K.
Technically, aren't those primary colors?
Yeah.
Yeah.
Because what's one of the characteristics? You can use it to get any other color. So you can mix red, green, and blue to get any color in the spectrum. You can also mix cyan, magenta, and yellow to get any color in the spectrum. What device uses cyan, magenta, and yellow?
Printers, sir.
Exactly. So the printers is working with primary colors, but it's not working with red, yellow, and blue. What device uses R, G, and B?
Like phones?
Anything with screen, anything with a light.
Monitor, yeah.
Exactly. So therefore, that is how your monitor achieves color, by mixing any one of these pixels together. But subsequently, that is also how any program on the computer works. It shows you colors by mixing these together. Now, the thing is, remember before we looked on a grayscale image, and we saw that a grayscale image has 256 shades of black and white. Now, in this case, we have 256 shades of red, 256 shades of green, and 256 shades of blue. And that is really how you get a colored image now. So think about it. Your computer is able to display any mixture of red, green, and blue on any scale between 0 and 256. So think about the amount of options that you have with that, right? So, you know, you can, let's say on this scale, if I would draw like 256 lines here. So in the red, I could say, okay, in line 210, red, mixed with green, line 15, mixed with blue, line 156. I'm just saying you can mix any shade of any of those three colors together. So in total, it's possible to get 16 million colors. If you have red, green, and blue on a scale of 0 to 256, then when you work out that maths, you can get 16 million colors. Now, fun fact, the human eye only sees up to 10 million colors, right? On average. So that would mean that any image that you get by mixing these colors together, chances are the human eye can well and pick it up. Now, how you represent that is that for the red channel, it is 2 to the 8, green 2 to the 8, and blue 2 to the 8, because each of these give you 256, 256, 256. So in the background, that's really what the computer is doing. The computer is saying, hey, for this red pixel, it is, what shade is it? For this green pixel, what shade is it? And for this blue pixel, what shade is it? And then it overlaps all of those pixels together to give you the resultant of that color. Just like you mixing red and green to get purple. No, red and blue to get purple. You understand? It would mix a red pixel and a blue pixel, and then you would get purple pixel from it. But then if you mix like a lighter red with a higher blue and a little bit of green, you get like some other color. Okay, so that's really what your computer and your monitor is doing. Now, so this type of image is called an 8-bit image. But it has a bit depth of 24 bit. So yeah, I know things are getting confusing now, but remember, the bit depth is the amount of colors you can get out of it. And remember, we have 3 shades, red, green, and blue. Each of them, you're getting 256 possible shades and combination. So it has a color depth or a bit depth of 24 bits. But it is an 8, let me put this into perspective. All right. Okay, so let's look at this other, wait. Okay, so let me say that for you. So this grayscale is 8-bit. It is an 8-bit. It has a 8-bit color depth. That's the proper way to say it, because it has 256 shades. This is 24 because it has 3 channels, each capable of going to an 8-bit color depth. Now this image, remember our trusty PNG images? So our PNG image has a 4th channel, and that channel is called an alpha channel. Sounds familiar?
Yes, sir.
So for a PNG image, what do you think an alpha channel would tell the computer?
What's transparent or not?
Exacto mundo. So this is why a PNG image, it has 8-bit color depth, which means it has 256 possible shades of each channel. but it is really a 24-bit image. It's a 32-bit image because it has 4 different channels. So this is why PNG images are a little different, because it has this additional color channel. Now, not every device can read an alpha channel. So for example, you might have a phone that when you try to display a PNG file, it doesn't show, because apart from getting the information, what is red, green, and blue, it has this other thing that it can't determine. Okay, so let's move on. So what if an image was capable of showing possibly, Nate, stop shaking the camera. You're shaking the camera. Let's say that you had a phone that was an image that has a 16-bit color depth. So what this is saying is that instead of having 256 shades here, it has 65,000 possible shades. Now remember, the human eye kind of tops out at 10,000, right? 10 million colors. In this case, it would have 281 trillion colors. So you might say, well, why would you have a 16-bit color depth image? Because on the internet, you might see an image, and most images, 99% of all images you get on the internet or everywhere, has an 8-bit color depth, meaning 256 shades of possible color per channel. But there are images that have 65,000 possible shades of channel. So you can, possible shades per channel. So you can just imagine how big that is. But to you, it would look no different than a 8-bit image, because the human eye can only pick up a certain amount anyway. So you might say to yourself, well, why do these images exist? It's not like it went sharper. Remember, this has nothing to do with resolution. Resolution is how much pixels make up the image, and that makes the image sharper. This just has to do with how much color information you're seeing. So if you look on this chart, you can see that, okay, most monitors are able to show like an 8-bit image, which really has 256 shades. So does the human eye. And this is why you wouldn't find, for example, monitors that can go up to like 10-bit, like meaning show you way more colors than 256 shades. Because the human eye can only perceive 10 million colors anyway. And this is why technology stopped kind of pushing, stopped developing photographs in a higher realm. And even up to today, the most expensive monitors can't show you more than 10-bit color depth. Remember, this has nothing to do with resolution. This is the amount of colors you're seeing. Remember, it's very easy for you to find out when you're showing less color. So for example, if you look at a 4-bit image, you can see the difference between a 4-bit and an 8-bit. You're going to start seeing it. You can definitely see the difference between a 1-bit and a 4-bit. But going higher than 8-bit, to you, it would just look like a regular image. So when you look in Photoshop, right, and a lot of persons don't know what this option is in Photoshop, but they see it all the time. In Photoshop, under image mode, you notice you see all of these modes here. Well, you know what RGB is now, right? You know what CMYK is, so you know they're all primary colors. So basically, if you open an image in RGB, then the colors you're seeing here is being generated as a result of mixing red, green, and blue. If you choose CMYK, then the colors you're seeing is mixing cyan, magenta, and yellow. But if you look down here, where you start seeing 8-bit, 16-bit, 32-bit, and some persons, this is how you know what this means. This is how many colors per channel. So by default, Photoshop is usually always an 8-bit because every image that you get has 256 colors. We already identified that a 16-bit image don't make much sense because your human eye can only pick up around 256 colors anyway. So you might ask, why is there even a 16 and 32-bit color channel? Now, the reason that you have these now is going more into the advanced realms of computer. If you were a robot, which probably we will be in the next couple of years, who knows? But if you were a robot, you would see a difference between an 8-bit image and a 16-bit image. Because, you know, you wouldn't have human eyes, you would have like robotic eyes or whatever, right? But the thing is, when you're doing, when you're going to do more advanced rendering work or work with 3D modeling and rendering and lighting, then what happens is that color goes further than 256 shades. And when it goes higher than 256, it goes into the kind of like the light spectrum. So your eyes are only seeing white, but there is actually like information embedded in that. And let me show you the difference here. And then you see what I mean. Why some photographers will go out and buy a really expensive camera that can take a 16-bit image rather than the typical everyday camera, which can take an 8-bit image. So I have here with me a photo here, an 8-bit image photo. And where is my other example? Right, and I have a 16-bit image that has a color depth of 32. So I have a color depth. First, I have a color depth of 8 and a color depth of 32. So let's open the 8-bit color depth image, which, I mean, that looks like your average image. So let me open that in Photoshop. And that is it there. Nothing special. It's just, it's a panoramic view of like a landscape. And let me clear this here. So when you look at this, you say, okay, it's an image. It's a little bit, what you call over bright, but it's an image in the middle of the day. Now check this out. If I, remember this is 8-bit, right? 256 shades per channel. So if I go to like adjustments and I go to like exposure, for example, come on, and I, you know, make the exposure less or more, then, you know, it does what it's supposed to do. But remember that this exposure is working with only every pixel having possible 256 shades. Now, what if I give it a bit more than that? So what I have here now, I have a 32-bit image here. And notice that it doesn't even come up as an image. As a matter of fact, if I send this image to you via WhatsApp, your phone can't open it. Chances are your computer can't open it, but only Photoshop can open it. And this is because it's not getting those 256 channels. It's getting like, where is my thingy? No. Stop. Okay, it's getting, sorry about that, right. Stop it. All right, it's getting way more color. So let me open this image now in Photoshop. Open with Photoshop. And there you go. So they look pretty much the same. I can put them side by side. Can I? Yes, I can. They look pretty much the same, but this is where things will differ. Image that has more information, meaning more color, is capable of showing you much more things. It's just that you can only perceive it in a range of 256. So if I go to exposure and I adjust the exposure here now, what you notice is happening to this image. I mean, you might notice something different happening to this image. Maybe you can't explain it, but tell me what you think is happening to this image.
Sir,
It's exposed the natural light that was taken in.
Not quite. Not quite. Let me adjust the exposure here. Exposure, where are you? Here you are.
Oh, it's able to tell the colors that you're seeing with the sunlight differently in the one with more.
Right. Okay. So you get
So it's able to adjust it independently in that one, but not in this, because this is just seen as white alone.
Ah. So you're getting, I think that's as warm as we can possibly get in terms of explaining it without a bunch of scientific jargons, right? So essentially what is happening is that because there is more than 256 bits of information, remember you can only see 256 at a time because that's what the human eye can see. So in this white here, there are colors that goes beyond the visible spectrum. And it's actually there, but you can't see it because the computer screen and your eyes are not able to like look into the white to see that within the white, there is blue within the white. But when you go in Photoshop, you can dive down into that range to pick it up. But you can still only take in 256 at a time. So now it's like clipping the lower values and going into the higher values. But essentially at the end of the day, this image has more information. So what that means for a digital artist is that if you had a really expensive camera and you could take a 32-bit image, it's like embedding, you ever take an image in the sun and when you look at it, it's just white, right? Or you might take an image with a light, it's just white, but there is more information in that image, but your camera is not able to capture it because it tops out after it reached 256. Now for cameras that can pick up more than 256 now, you're able to get the information within the bright light. And what that means for you is that for in terms of doing editing, like doing photo editing, I could adjust the exposure of this image. I could adjust different sections of this image at different exposures because all that information is there to play with. One of the most popular use of this type of image is what you call HDR. For those of you interested in like rendering and all of that, you might hear the term HDR rendering. That is getting confused now with TVs that you see that says it supports HDR, but that's a whole different conversation. But essentially what that is in rendering terms, when you have a 3D scene, instead of throwing in like a 3D light, what you would do is you would take an image like this, place this image as your background, and what would happen is that the values that go beyond 256 start acting as light. So it starts actually shooting light into your 3D scene and it makes it look way more realistic. So 32-bit images are really for like persons who are like into this kind of digital photography, kind of 3D visualizations, or maybe photo editing. anything with that range where you can pull more information out. But for the general masses, an 8-bit color depth is just fine. So whenever you see an image and you right click it and you go to properties and it says it's a 24-bit image, right? This is just the takeaway. Let me go back to PowerPoint. Right. When it says that it is a 24-bit image, it simply means that it has 8 bits of color depth per channel. That's really what it is saying. And when it says, when you see something that says an 8-bit color depth, it's simply saying that it has 256 possible shades of color. So that is all you need to know, because you might see TVs that are rated at like 10-bit color depth, and you're wondering, what's that? And you're thinking it's resolution, which is not resolution, it's the amount of colors it can display, right? And the more colors it can display is the more real, I guess you could say it would look. But as I said, the human eye tops off at about 10 million anyway, so we are pretty much as real as it can get for the typical monitors and TVs nowadays. So unless you're a robot that can pick up more than 256 range, then anything with 8-bit is pretty much okay. Anyway, so that is our discussion on bit depth. I hope we know what it is now, right? And most devices can only read 8-bit, most devices, all right? But if you see a camera out there and it says that it's 10-bit, then you know exactly what it is saying. It is able to capture a whole lot of colors, a whole lot of shades of colors. Right. Okay, so that ends our lecture for today. I've gone a little bit over the time. What will we be doing Wednesday? Wednesday we will be doing
Exercise 5.
Exercise 5, which is kind of like the second to last exercise. It's kind of like the last exercise of this phase. We're doing 3D modeling. So you will need SketchUp to do this. You can use it in a browser if you want, or you can just try and see if you can get the pro version. You're going to need that for the assignment. You will not need, but it will make life a little bit easier for the assignment. But for the exercise, you can get the free version, which is available on sketchup.com, or you can even use it in a browser. It's up to you. All right, so we're going to go into 3D modeling and exit the world of 2D. Yeah?
Remember, I sent you a message
about the Illustrator?
Everything.
Yeah. Okay, so hold on, repeat what you said a while ago. About what?
About everything. None of them are opening.
None of them.
Sir, Alia Cookman speaking. Also sent you an email. I don't know if you saw
Yeah, man.
it.
Is it your name? I saw a couple.
Okay, sir.
I saw a couple. I don't know what to tell you at all, because
Sir, what on for the grades?
I should post them.
Sure.
By Wednesday or close to Wednesday.
My thing is,
what's your thing?
I'm not seeing my grades from last year there. I'm seeing the blank slate.
Were you seeing it before?
Yep.
Hold on, you are carrying over your grades from last year? Okay.
And I sent you an email and you said, okay, you're keeping them, and then oops, them disappear.
No, but hold on, that's what I'm saying. Didn't I put it in?
Wasn't there, you know, and then I checked last week to just make sure it says still there. I check every week. And last week it was blank.
Oh, even though it was there. Okay. Hold on, let me check on that.
I can't remember if I did the last of the 5 assignments. So I guess that's a bit.
Jessica. All right, the computer challenge. I don't know how to solve that one. That grades thing, much simpler problem to solve. On Wednesday when we meet again, I want you to check again to see that it is.
Sir, one.
Repeat that question.
Sir, no, I don't have Illustrator on my laptop.
No Illustrator and no solution work for you. No solution work for you either, as it relates to
I'm supposed to be going to Mr. Neville today
No.
to try and find a solution to the problem, but for right now I don't have Illustrator.
Meaning when you try to put it on, you're the one that it
Not
was working.
It's not installing. Yes, sir. It's not installing.
Yeah. So I'm praying that he can help, because when it goes into the technical realm, there's not much that we can do remotely. You understand? The most we can do is give you a hope that it works. But when you have to know troubleshoot to see why it's not working, it could be that there's another version or some other program that's preventing it from work. So you just have to.
Sir, I tried the 2017 version and it installed, but it's not opening or anything. It's not working. And when I tried to uninstall it, to reinstall it, it didn't. It wasn't uninstalling either. So Mr. Neville was telling me that maybe it's my operating system is a problem.
Yeah.
So now I have to go and see with him.
Yeah. That's the thing, guys. I mean, if you're having technical problems like that, I don't think that is something that you can really tell you about over the phone to try, because next thing you're going to do something and then the computer totally. So I would say if you can do the same, if you don't already have like a technician or some computer guy in your community or in your family that you normally check to help you with these things, then your best bet is to see if you can somehow, in a socially distant kind of way, see if you can let Neville help you out. I also hear that sometimes the technicians at UTech, like they also, I think, try to help. I don't know if anybody ever worked with them before. But at the end of the day, you need like some techie person to help figure out why it's not working.
Yes, I have a question. Are there like softwares where you can share screen people from other places and then they can fix the problem for you?
That is true. You can use share screen, but what name, the blue one, Team Viewer, even the one that I recommend for the virtual lab, which is AnyDesk, which is my favorite. But the thing is, like when you do things like restart, like if the computer don't boot up and log in, it's like you're totally locked out. So, you know, if it's something simple like change an option in a program, then yeah, man. But when it involves now, you have to uninstall and change like your startup things and, but it's up to the technician, you know. I mean, some technicians will feel confident about doing that, and others, they will say, no, better them just carry it come so that I can just fix it. It's up to whoever is working on it. But like Mr. Campbell, he knows about those solutions. I mean, him do that sometimes with people. So if him say that number it best not to use that way, then I guess it's probably a reason. Him don't want to do something and then you totally don't have the use and then you can't link up. So you're stuck with the computer not working totally. But such is the life of computers. I mean, you know, it's going to give problem. I mean, you know, it's just how it is. The most I can do is try and educate you about it as much as possible. Yeah. Next question.
Sir, on the grids. Oh, sorry.
I'm marking it. I'm going to post it. I was just kind of, I just mark a few and then post a few So I'm going to post it, man. You whatever, however far I reach, you'll see it by next class. Yeah, next. Question.
Where is Mr. Campbell? Because my tech guy said he's not sure what to do. So.
Well, Mr. Campbell, he's based on University Crescent, but he's always on the road. He's like a technician. Him go around to like different offices and fix stuff. So because I have an office there at University Crescent, but it's not open now. Everybody working from home, so it's closed. So you have to call him to see where he is. That's the best answer I can tell you. It's not a store that you can just go to. It's really just it's like a home office, and he has a section that he normally stores all his stuff there. So you have to call him to kind of schedule. Sometime, from what I know, sometime he would even meet like on campus. Like if it's a simple problem and him need to him can just see you with the computer and whatever he would probably meet you on campus, like I don't know, so under the tree or somewhere over CSA. It depends. But he's based at University Crescent, so he's close. That little Crescent across from UTech, but he's not always there, as I say. What you do for those who are having technical problems, you can, when you're submitting your work, you need to put it in the comments dialog box, all right? So that I know. You definitely need to do that. Yeah. But it's not out of the ordinary. I mean, every year is the same thing. That's why I asked Mr. Campbell to be like the kind of unofficial technician. So this is pretty normal. Some of us are going to have computer issues. That's just how it is. And you're going to have it every year. And you're going to have it right before you're finishing your studio project. Something going to not work. Adobe going to not work all of a sudden. Or AutoCAD. Or some crap is going to happen. And you have to run and find somebody quick to reinstall something so you can print your drawing and whatever. It happens. It happened to me. It happened to everybody. It's the computer. You know? And if it wasn't the computer, then it would be equipment, you know, your pen or your Prismacolor markers or your sheets or whatever, you know, it's just the life of CSA. Yeah. All right. So,
I don't know if you said it already, and if you did, I am bad. I'm sorry. But what applications will be used in next class?
Right, so it's SketchUp, using SketchUp next class. All right. You will have better luck with SketchUp than the Adobe
I don't
stuff.
like SketchUp.
Say again?
I don't like SketchUp because I was doing a project once and like I turn back and the whole thing gone. So make it
but every program has that capability. SketchUp just happened to be the one on that day.
No, it doesn't more often. SketchUp, you have to save it every minute. It comes like you have a relationship. It needs enough reassurance.
If anything, I would say that more of Illustrator than SketchUp or Photoshop. I mean, Illustrator has done me bad in the past, you know? Photoshop autosave is pretty good. And I don't know if you realize, but while you're using Photoshop, because of how it works, you can save while you're working. Right? Like most programs, you know, you click save and you wait, you know, a couple seconds, and when it's done save, you continue working. But Photoshop allows you to save and continue working. So the nature of how it works, it's easy for you to recover a file. But SketchUp, I mean, right name? Illustrator? SketchUp as well, I don't think it has like good autosave either. So, right. Yeah. So, yeah. But we won't be doing anything really complex. So, you don't have to worry.
Sir, by Wednesday class, if I check and I don't see the grades there, I'll have to do the classwork.
Well, actually, before I was trying to answer the other questions, I was just trying to confirm that. I had confirmed that your grades were there.
I have an email.
Okay, good. So it's there. So yeah, you don't have to worry. It's just probably not in the spreadsheet. I thought I had put it there, but I think it's somebody else.
I'm not so sure about the last project if I did the final number 5 project.
Well, let me tell you right now. Let me tell you. By the way, guys, if any of you want to leave, you can. Technically, class is done. So I'm just saying. If you're tired of my voice, I know you can escape. I'm looking for Jessica's past grading report. Let's see here. For DDM. It's coming up. Oh, it was coming up. 1819. J.
Oh, yeah. I wonder what's yours about. Yeah, I'm thinking 1819. This year is 19. I don't know. Last year, sorry. Last year. Don't know. Very slow.
And those 18, 19. Let me check. No, it would be 1920. Because we know in 2021. Yes, it is here. Okay, let me tell you what you did. Don't worry, I won't disclose your grades. I'll just tell you.
Oh, okay. All right.
So you did, where's the exercise? Totals. Yeah, but do I have your name highlighted here? Must have highlighted it for a reason. Come on, where are you? Okay. Yes, you did all the exercises. 1 to 5.
Assignments.
It's coming up. You did. No, but you didn't do the assignments. Right, so it's like after the exercises. So you need to do the assignments. So assignment 1, final project, and portfolio. All right?
Yes, sir.
But the exercises, you have done them. You know, you can always do exercise 5 again. I'm just saying.
Okay. I have other stuff to do, you know, studio and everything.
Okay. All right, so that is your status. I'm going to copy over those grades now so that it's in this year's thing. So you should see them now.
Blessings. Appreciated, sir.
All right. Is there any other requests? Okay. I realize I'm getting a lot of requests in the credits, you know, because the end of the lecture, so in the credits. All right, so I guess it's safe to adjourn this class now until Wednesday, right?
So long, farewell.
Okay, so long and farewell. All right,
Thanks,
bye.
sir.
Okay, stay safe.